first. So we have to find electric field intensity at a point 0, 4, 10 due to two infinite line charges carrying a line charge density of 8 nanocoulomb per meter, each located at x is equal to plus minus 4, y equal to 0. Now here we have two line charges. So this is my coordinate system x, y and z. The line charges are placed at x equal to plus 4. This is x equal to plus 4 and at x equal to minus 4. So we have two line charges. Now what we have to do is we have to find the electric field intensity at a point due to these two line charges, and the point given in the problem is 0, 4, 10. So it is x equal to 0 surface, and on that we have the value of y as 4 and z as 10. So it is somewhere on the yz plane at x equal to 0. Now since we have to find the electric field at z equal to 10 point, so what we will do is along x equal, so due to this line charge, what we will do is we'll take the perpendicular distance. So let me assume that the point is somewhere here at y equal to 4 and at z equal to 10. So this is my 0, 4, 10 point. So now we have to find the electric field intensity at this point due to these two line charges. So what we will do is we will take the perpendicular distance. So therefore in these cases my source point is 4, 0, 10 and destiny is 0, 4, 10. This is first case. And in the second case, my source is at minus 4, 0, 10 and the destiny is at 0, 4, 10. Now, this 10 is common. We have taken this deliberately because we had to take the perpendicular distance. We had to take the row. So we can take the row from any point. Since here z is equal to 10 is given, so therefore we have considered the source also at 10. We were given the location of source at x equal to 4 and y equal to 0, but z location was not given. So z location has to be taken same as the destiny z location. So now I'll calculate the a row vector first, that is the radius vector. So this will be minus 4ax vector plus 4ay vector divided by under root of 16 plus 16. So which comes out to be minus 4ax vector plus 4ay vector divided by under root of 32. So this is the electric field intensity, sorry, this is a row due to the first line charge which is located at plus 4, x equal to plus 4. Now in the second case, my source is at minus 4 comma 0. Z location is going to be same, and again destiny is 0 comma 4. Now again we will find the arrow in this case. So arrow vector will be again destiny minus source. So this will be 4ax vector plus 4ay vector divided by under root of 32. So now the electric field will be, so at any point the electric field is also is always found by using the superposition theorem. So electric field will be equal to sum of the electric fields due to each line charge. So this will be rho L divided by 2 pi epsilon naught into rho a rho. So let me consider this as a rho 1. This is a rho 1 and this is a rho 2. So this is a rho 1 plus a rho 2 vector. So just substitute the values. So rho L, that is line charge, is 8 nanocoulomb. So 8 into 10 to the power minus 9 divided by 2 pi into 10 to the power minus 9 divided by 36 pi into rho is root 32. So we will have root 32 here into a rho 1 vector is minus 4ax vector plus 4ay vector divided by under root of 32 plus 4ax vector plus 4ay vector divided by under root of 32. So pi pi gets cancelled. 2 18s are. Now here if you take the LCM, 4ax and this minus 4ax gets cancelled. So I left with 8 into 10 to the power minus 9 into 8 into 8 ay vector. Sorry, this is 18 divided by, we have 32 over here. 32 into 10 to the power minus 9. So 10 power minus 9 gets cancelled. So 8 4s are and 4 2s are. So this is 36 AY vector. This many volt per meter. So this is the final answer. Next question. We are given with D is equal to, D vector is equal to Z rho cos square phi into AZ vector coulomb per meter square. This is D vector given to me. Now we have to find the volume charge density. So from Gauss law we have rho v is equal to del dot D vector. Now this is very simple problem actually. Here we have to find divergence in cylindrical coordinate system, because the D vector given to me is in cylindrical coordinate terms. So therefore we have to find the divergence in cylindrical coordinate system. Fine. Now we have to find del dot D. So we have only Z component, and when you have only Z component, so in the resultant, so when we find the divergence, only Z components will be multiplied. So therefore what we will get is, we will get d dz divided by dz. That's it. If you observe the, if you expand the divergence, you will the z terms remain will be this. Now if you differentiate this dz, that is the z component of d vector with respect to z, you will get the value as, okay, and we have to find the volume charge density at, actually in the problem it is given, we have to find the volume charge density at this point. So therefore, if you differentiate this, what you will get? You will get rho into cos square phi. So if you substitute the values of these coordinates, so we'll get rho v is equal to, the value of rho is 1 and cos phi is cos pi by 4. So it comes out to be 1 by 2, which is zero point 0.5. Now this is when AZ component is given. Suppose that instead of AZ, my question is, so repeat above problem for d vector is equal to, again d vector is given to me same, but the component present is a rho here. In this case it is a rho. Now again we have to repeat the above problem, so we have to find the volume charge density at the same point. So here rho v will be equal to del dot d vector. Now in this case d has only rho component, so therefore if we find the del dot d, I'll get 1 by rho, here I'll get rho also, so it's rho d rho. So this is after expanding the divergence. Now if I substitute the value of d rho, 1 by rho d by d rho into rho square z cos square phi. Now if you differentiate this, you will get 2 times z into cos square phi. Now if you substitute the values of z and phi over here, you will get 2 into, the value of z is, 3 into cos square pi by 4, 3 centimeter square, 3 coulomb per meter cube, sorry. So the rho v will be 3 coulomb per meter cube. Next question is that we have to move a point charge of 5 coulombs. We have a charge of 5 coulombs which is located at 6, 2, minus 3. This is source location, to a point whose locations are 9, 4, 1. This is destiny. Distance is 2 meter. Now also electric field E vector is equal to 4 AX vector minus 3 AY vector plus 5 AZ vector is given to me at 6, 2, minus 3. So what we have to find is, we have to find the work done. So how much work is done how much work must be done in order to move this point charge from 6, 2, minus 3 to 9, 4, 1 point location. Now work done W is equal to Q into E vector dot dl vector. Now the electric field is in this direction. It is also given in the problem that electric field is in the direction of is in the downward direction. So this is the direction of electric field. Now what is dl vector over here? So dl vector will be dl into al vector. Al, that is in the direction of al. So what is al? Dl is 2. The distance is 2 meter. Now al vector will be the destiny minus source. Again it's destiny minus source. So this is 3ax vector plus 2ay vector plus 4az vector divided by its magnitude is under root of 29. So this is the direction in which I have to find the work done. Now W will be equal to, what is the charge? Charge is nothing but 5 coulombs. So 5 into, what is electric field? Electric field is 4ax vector minus 3ay vector plus 5az vector. Now dl is 2, the distance, and al vector is 3ax vector plus 2ay vector plus 4az vector divided by under root of 29. Now if you solve this, the work done would come out to be 260 divided by under root of 29. These many joules. Next question is find E vector at 2, -1, 3 due to a potential of V is equal to 3x square y into z. Now here we need to find electric field and the potential is given. So there is a relation between electric field and the potential, that is E is equal to negative gradient of potential. Now since the given coordinate system is Cartesian coordinate system, so it is very simple. It is dv by dx into ax vector plus dv by dy into ay vector plus dv by dz into az vector. Now what is dv by dx? So dv by dx will be 6xyz, dv by dy 3x square z, and dv by dz is 3x square into y. Just substitute these values in the electric field equation. So E vector will be equal to minus of 6xyz ax vector plus 3x square z ay vector plus 3x square y az vector. Now the values of x, y, z are given to me. X is 2, y is -1 and z is 3. So minus, if we substitute these values, this will be minus 36 ax vector plus 36 ay vector minus 12 az vector. So the electric field will be 36 AX vector minus 36 AY vector plus 12 AZ vector. Next question is, there is a dipole whose moment P vector is 3AX vector minus 5AY vector plus 10AZ vector nano coulomb into meter is located at Q of 1, 2, 4 in free space. Find the potential at P of 2, 3, 4. Now here the source is 1, 2, 4 and the destiny is 2, 3, 4. The potential due to a dipole, we have already seen that the potential V due to a dipole is given by Q d cos theta divided by 4 pi into epsilon naught r square. This QD is nothing but, this QD cos theta can be written as P vector. P vector is nothing but the dipole moment dot AR vector divided by 4 pi epsilon naught into r square. AR vector is AR vector. How will I find AR vector? AR vector is destiny minus source. So it is AX vector plus AY vector divided by under root 2. This is AR vector. So potential is moment 3 into AX vector minus 5 into AY vector plus 10 into AZ vector into 10 to the power minus 9 because it is in nanocoulombs divided by 4 pi into 10 power minus 9 divided by 36 pi into r square. R square will be 2 and we have AR vector also. So dot AX vector plus AY vector divided by root 2. If we solve this, we will get 3 minus 5 into 9 divided by 2 root 2, which is equal to minus 6.36 volts. So this is potential due to dipole moment. Now we have come across a new term called dipole moment, which is nothing but charge into distance. There is one more problem, that is to find the electric field due to a dipole moment now. So the question is, we have to find electric field. So find E vector at 0, 0, 5 due to a dipole of moment. Now the dipole moment is given in this case 1 AZ vector. This is the dipole micro coulomb meter at origin. So the dipole is present at the origin and we have to find the electric field at 0, 0, 5. So for this, the electric field, we have seen that electric field is Q into D divided by 4 pi epsilon naught R cube into 2 cos theta AR vector plus sin theta A theta vector. Now, if you observe the 2 points, the destiny point is 0, 0, 5 and the source point is 0, 0, 0. So the angle theta between them is 0 degree. There is only a difference of z coordinate. So therefore, the angle theta is 0 degree. So theta is equal to 0 degree in this case. So therefore, electric field will, this Q into D is called as the magnitude of dipole moment P divided by 4 pi epsilon naught into R cube into 2 AR vector. Now the magnitude of dipole is given to me is 1. So 1 into 10 to the power minus 6 divided by 4 pi into 10 to the power minus 9 divided by 36 pi into what is R. Now we did not find AR vector over here. Okay, let me find that also. AR vector is nothing but 5 AZ divided by 5. So which is AZ vector. So what is the magnitude of R? So magnitude of R will be 5. So small r will be 5. Small r is 5. So this is 5 cube into 2 AR vector. So if we solve this, we will get the result as 144 AR vector. So these are the few problems based on electrostatics concepts. Now let us solve few problems based on magnetostatics. Magnetostatics. Now question is, if a vector field F vector is equal to x plus 2y plus az ax vector plus bx minus 3y minus z ay vector plus 4x plus cy plus 2z az vector is irrotational, then find the values of A, B, C. This is a problem. Now, we know that for a vector to be irrotational, its curl must be equal to 0. So, if we take the curl, so del cross F vector is its AX vector, AY vector and AZ vector, d by dx, d by dy, d by dz, x plus 2y plus az, bx minus 3y minus z and 4x plus cy plus plus 2z. So this is the cross product. Now if we find the cross product, we will get ax vector into c plus 1 minus ay vector into 4 minus a plus az vector into b minus 2, which is equal to 0. So curl must be equal to 0 for the vector to be irrotational. Now if we compare the ax, ay and az components, we will get c plus 1 equal to 0, which implies c equal to minus 1, 4 minus a equal to 0, which implies a equal to 4, and b minus 2 equal to 0, which implies b is equal to 2. So these are the ABC values which we got for the given vector to be irrotational. Okay. Next question is the h vector, which is x square ax vector plus 2yz ay vector plus minus x square az vector, it is given. So find j vector at point 2, 3, 4, 6, 45 degrees, 3, 3, 60 degree, 90 degrees. So at these 3 points we have to find the j vector. Fine. So by Ampere circular law we know that j vector is equal to del cross h vector. So if we find del cross h, so del cross h will be ax vector into 0 minus 2y. You just expand this, you just solve the determinant, you will get this result. Ay vector is minus 2x minus 0 plus az vector is 0 minus 0. So we will get the result as minus 2y ax vector plus 2x ay vector. Now the first point is nothing but the Cartesian coordinates. The first point is, so a at 2, 3, 4, j vector is, so the value of x is 2 and y is 3. So minus 2 into 3 ax vector plus 2 into 2 ay vector. So this is minus 6 ax vector minus 6 ax vector plus 4 ay vector. This is in Cartesian coordinate system. Next, the second point given, the second set of point, the second coordinate which is given in the problem, it is in cylindrical coordinate system. So r, rho, theta and phi, rho, phi, z. So b at 6, 45 degree, 3. Now first of all what I have to do, I should convert this into Cartesian coordinate system. So we know that x is equal to r cos phi, y is equal to r sin phi, and z is equal to z. R is 6, rho cos phi, this is rho sin phi. Okay, so rho is 6, so 6 cos 45 degrees, it is 4.24, y is also same 4.24, and z is equal to 3. Now we have got the values of x, y, z. So therefore j vector will be equal to minus 8.48 ax vector plus 8.48 AY vector. Then third point is 3 comma 60 degree comma 90 degrees. So again we have to convert this into, so this is r, theta and phi. So again we have to convert this into Cartesian coordinates. So x is equal to r cos phi into sin theta. Y is r cos phi, sorry, r sin phi, r, let us write this in order. This is r sin theta cos phi. This is r sin theta sin phi, and z is equal to r cos theta. So if we substitute the value of r, theta and phi, we will get 6 cos 90, sorry, 6 sin 6 sin 60 degrees and cos 90 degrees. So this is 0. Cos 90 is 0. Then y is 6 sin 60 sin 90. So this is 2.59. And z is 6 into cos 60. So cos 60 is 1 by 2. So this is 3. So anyhow, we need the values of x and y. X is 0. So therefore, the j vector will be minus 5.18 into ax vector. That's it. All the other components will be 0. So let us consider one last problem. So a magnetic field in air is measured to be b vector is equal to b naught x by minus y by ax leads to this field. So this is the question. So what current distribution will lead to this field? Now there is a hint given over here. The problem in the hint is the algebra is trivial in cylindrical coordinates. So what he is saying is the algebra is trivial in cylindrical coordinates. So what we will do is, first of all, we will convert the given magnetic field into cylindrical coordinate system, because as per hint, the algebra is very trivial in cylindrical coordinates. So therefore what I'll do is I'll find the value of b rho. because in cylindrical coordinates my coordinates are rho phi z. So b rho will be, so b rho will be b vector dot a rho vector. Now what is b vector? So this is b vector. Now what is x? So b vector is b naught into, let me write this in cylindrical coordinates. So x can be written as rho cos phi divided by x square plus y square is rho square into ay vector dot a rho vector minus y is rho sin phi divided by rho square ax vector dot a rho vector. So this comes out to be 0 because ay dot a rho is, okay, let me expand this. So just let me write this. Okay, so ay dot a rho is sin phi, whereas ax dot a rho is cos phi. So if you substitute these values over here, you will get this as 0. Since, let me write here, ay vector dot a rho vector is sin phi, whereas ax vector dot a rho vector is cos phi. So therefore b rho is 0. Now b phi, so b phi will be b naught, similarly b vector into a phi vector dot a phi vector. Now this will be b naught into rho cos phi divided by rho square into ay vector dot a phi vector minus rho sin phi divided by rho square ax vector dot a phi vector. This is b naught by rho. This remains b naught by rho because this is cos phi and this is sin phi. This becomes cos phi and this becomes sin phi, minus sin phi, sorry. So therefore this comes out to be cos square theta plus sin square theta, which is 1, and we will left with the remaining terms. So b naught by rho, and finally bz, which is 0 because there is no z term in the b vector. So therefore b vector which I have got in cylindrical coordinate system is b naught by rho into a phi vector. Now what I have to find? I have to find the current distribution, that is j vector. That I have to find the current density j vector. So from Ampere's law we know that j vector is equal to del cross h vector. So we can find h vector from b vector as, so we know that h is equal to b by mu. Since the medium is free space, so it is mu naught. So this is b naught by mu naught into rho a phi vector. Now if we find the cross product of this, it is a rho, this is 1 by rho. We have written the generalized form, so just substitute the values of h1, h2, h3 and uvw in the cross product. So this is a phi az d by d rho d by d phi and d by dz 0 b naught by mu naught rho into rho. This is rho into b naught by mu naught into rho and 0. Now if you take the cross product of this, you will get 0. So therefore j vector is 0 in this case. So j vector is equal to 0 will lead to this particular. So b vector was given. So this field is possible when j vector is 0. So these are few problems based on electrostatics and magnetostatics. You can solve many number of problems. Just have some standard textbooks and keep solving the problems so that you will be familiar with the problems.